Okay, we are back today with more Advent of Code. So if you haven't been following along, we're up to day 3 in the Advent of Code. I'm a few days behind because I don't stream every day. And anyway, I don't want to spoil things for people who don't want them spoiled. So I think it's nice to be a couple days behind. But yesterday we were able to do problem 2A, B, and 3A. So 3A was this problem where we needed to split up lists of items that are kind of symbolized by lower and uppercase letters. We had to split each one in half and then figure out the item that was shared between the two, and like get a priority from them and output that. So we did that. One thing to note is that one of my tests was failing yesterday, and it turned out to matter, or it turned out not to matter, but I hadn't actually worked out why. So I worked it out off stream. Basically, we had eyeballed this and seen that Q, lowercase q, looked like it was on both halves, but it was not on both halves. So these are actually on the same half. And so lowercase q was not the right answer. Uppercase M is in both halves. And so once you do that and update the test, everything works. So cargo test problem 3 is going to fail once because we haven't actually done problem 3B yet, but otherwise it's passing. So that's what was going on there. And we get to part 2. So let's get to it. Part 2, as you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, capital B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, no one wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that's common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different item badge type. So in the above example, the first group's rucksacks are the first 3 lines, the second group's rucksacks are the next 3 lines. In the first group, blah, 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 it's the example, and then you have to find the priorities and sum them up, just like last time. So basically, instead of splitting up one line into each half, we're taking 3 lines and we're finding the common element among them, and then we're working out which what the priority for that item is. Makes sense to me. So let's go ahead and be disciplined about this. Let's put in the example input first. So let example be something like this. And we will take okay, so it's the same example. It's this example, which I already have. So let's just paste that in. Okay. And what to say about this? We want to say that in the example above, hit in the wrong place. Okay. Okay, so the solution to the problem then should be 70 if it's run on this guy. So let's assert that solve problem O3b example is, what did I just say? 70. Okay. And then I think I'm not going to bother with the shortened input because it's kind of a pain, and we already have an example right there. And cool. Okay, so we already have a way to get priorities. So the main thing we need now is a way to parse the input into groups of 3 lines apiece. Obviously, this can be done just by popping elements off 3 at a time. I'm thinking about whether there's some clever way to do this with iterators. So zipping them doesn't quite work. If we skip 3, that doesn't work either. I guess we would want to, I guess we could zip skip 3 of them and then take every 3 elements. Oh wait, but I think I already wrote parses string chunks. That's not what I want. I thought somewhere I'd written something that goes and gets every 3. Let me just take a look at what I did in my 2021 repo quickly. 21. Yes. Cool. Yeah, I already wrote a function for this. Okay. Let's grab that and drop that in here. Okay, and so basically this allows me to take an input of take a vector of some type and take a chunk size and parse it out and throw a nice result if you can't do it. So that's going to be useful. And I guess we'll do that within the solve problem. So let's just say let teams be chunk, what is it, input parser chunk input, and the chunk size is 3. And then we need to get the common element among those. Which is going to essentially be common element 3, exact string. I mean, there are definitely nicer ways to do this, but I think this is pretty much fine. We'll say S1 is a string, S2 is a string, S3 is a string. And I mean, my brain really wants to do this just over any arbitrary vector of strings, if I'm being honest. Which is actually doable in a pretty functional form. Let's just do that. Back. And we can say strings back string. And now this is strings dot into iter. And what to say? We want to map each of them into a hash map. S.chars dot collect hash map hash sets of whatever those are, probably chars, I guess. And then we want to reduce. No, we want to fold. And this is going to be hash set new, and the function will be accumulator. Oh, it actually can't be. Interesting. It can't be the empty hash set because that's not going to accumulate well. Dot intersection element. And that just returns a hash set, right? Intersection, do this, and then we can assert that the intersection has a length 1, and intersection dot into iter dot next unwrap. That's fine. Oops. Okay. Yeah, so now the only problem with this is it's not going to work. Has to be a function. Reduce works. Okay. Let's use reduce instead, and then we don't have to give this at all. And this is accumulator. Accumulator is a hash set of char. Intersection. And this just needs to be a interesting. I mean, it's going to be a little bit slow, but hash set char, accumulator intersection. If I collect this into hash set char. So accumulator is a hash set char. Element is a hash set char. But okay. Make all the types work. Collect. Let's put the reduce here. These are like really long. Accumulator intersection. Map. Collect. Reduce. Okay. Okay, and then this is an option. Why is this an option? It's an option because reduce needn't return anything. But let's say expect at least one element should be in the intersection. Is that the only case when this returns none? Yes. Should be in the starting vector. Okay. Looks like it works. And so now we should be able to say teams into iter. Map team, and we say get common element from back of team. Why is that a vector of strings? It's because this is a result. Say expect we should be able to chunk the input into thirds. So this is going to map it to its common element, and then we will get priority, and then we will sum that up. Okay. So I think in principle this should work. Let's quickly just test our get common element from back. Do I even know what these are? I don't. But that's okay. Assert equal, get common element from vec of v should be, and I honestly don't know, but we can just do it and then find out the answer. So it says it's R, and look at that, we have a lowercase r in all three of them, so that looks right. Cool, cool. And let's just do the other one as well. one will be these. And this is capital Z. And capital Z appears in all three of them. Cool. That looks good. Capital Z. Okay. So now we just expect that this should fail on the actual puzzle failure. And it seems to. So that means that also our example was passing. Hey Vimy, adventing. I am adventing. I'm on day 3. I'm a little bit behind, but adventing nonetheless. And I think we've just solved problem 3B. I'm gonna go ahead and throw this into the answers and find out. Let's take a look. 2508. Submit. Boom. Boom. Okay, day 3 finished. Let's do day 4. How are you doing today, Vimy? Also, your name makes me wonder if you're a Vim expert, and if so, I may have questions for you. Cool. Day 4, camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, your puzzle input. For example, consider the following list. Those are lists. For the first few pairs, this list means that this is a range that they've been assigned, and this is a route. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger amounts. Sure. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained in 4 through 6. Sure. In pairs where one fully contains the other, one elf in the pair will be exclusively cleaning their sections their partner will already be cleaning, so these seem like the most in need of reconsideration. In this example, there are 2 such pairs. How many assignment pairs does one range fully contain the other? Okay. Let's take a look and try to find out. So first, let's start with taking our test example and tossing it into this guy. Let example be a vector, we'll say, of this. Oops. And what is our input gonna be? I think we already have yeah, I guess we'll just have a parsing function for it. That's fine. So let's say that each one of these is just a string. Okay. Whoa. Too many cursors. Then we expect that solve problem 4a of example will be equal to And we can probably do the shortened input as well. This one seems pretty easy to visually work out. Okay, so what will be the steps to solving this one? This one seems pretty easy. We're going to first parse, we're going to split on commas, we're going to split each part on hyphens, and we're going to compare mins and maxes, and we have to remember to do it both ways. And we're pretty much done at that point. We could throw these things into structs if we wanted to, but I think this one's straightforward enough that we don't even have to do that. So let's just say, function parse, what are these pairs with cleaning pair? We'll just say s string into, and we'll call this usize. We want two pairs, so usize, probably. So we'll say let ranges be s.split on a comma. Dot collect it into a vec. We will assert that ranges.length is 2. And then we will say let pairs, I guess we can just return at this point. Return ranges 0 with the split again, a hyphen. I guess it's better to define another function here. Parse cleaning pair, we'll say parse range s, and actually this can be an str into usize, and this will be s.split on hyphen dot map, and then each of these needs to be parsed into an int, which is what? N dot parse u32 has to be positive, I'm kind of assuming. Dot expect should be parsable into a u32. N. I might need to format that message. I think I do. Cool, that formats, that expects. This is the end of the map. Then we collect. And we collect. This is the same situation as above, where we collect into a vector. Let's do some cleaning up here. Okay. This is a result. Oh, we can. No, I just want to expect there. Why doesn't it like that? The result. Format. Expect. This is where the map ends. function takes one argument, but oops. There we go. Okay. And then likewise, we can just say start equals that pair, do this. Start equals that pair dot length is 2. And then we return pair 0, pair 1. Okay. Oh, these should be U32s. Bingo. Okay. And then here we can say dot map s parse range s and return ranges. Usize. Let's do these as U32s. I don't, it's never gonna matter, but okay. Cool. And what's the issue here? Oh, right. We didn't actually range is 0, range is 1. Okay, so that will parse out our pair, and then we just need to compare them. Yeah, let's write that as a function too. Is subset. Let's say is subset left. Pair U32, U30. Let's go ahead and define some types here. Let's say type pair is U32, U32, and type, wait, that's wrong. Range. Type range is U32, U32, and type pair is range. This needs to be capital. Is range. Okay. And now we can update some of these. We can say, let's see if I can do this in a, no, S here. U32. Yeah. Let's do it this way. This is going to be a pair. Wait, we don't need these brackets. In fact, they might be bad. This is going to be a range. Okay. And then this can be a pair. And we can say let left equals pair dot 0, let right equals pair dot 1. If left dot 0 is, let's say, is left subset of right. So if left dot 0 is greater than or equal to right dot 0, and 1 is less than or equal to write.1. It's true, otherwise it's false. So if and only if. We need parentheses. This returns a Boolean. We didn't say we were returning a Boolean. And now we can say is right subset of left. And this is just let flipped be pair.1 pair.0. Actually, do we even need to do that? Can we just say is left subset of right? That. Cool. And then is pair, let's say is redundant pair, and that's just is left subset of right of pair or is right subset of left of pair. Yeah. And this needs to return a bool. And why is it not? There we go. Okay. This needs to return a bool. I like it. Cool, cool. And so now the question is just how many of them are redundant, which is easily solved. We just say input into iter map s parse cleaning pair s, and then say dot filter take p and we filter on is redundant p, and then we count. Input into iter gets us a bunch of cleaning pairs, and then we filter, and then we count. And count is going to return a U size, so we need a U32. Okay. Whoops. And what's the issue? Is redundant P. Oh. We can make this pair copy automatically. I don't actually know how type aliases work. Yeah, it's just copy automatically. Okay, I guess tuples automatically know how to be copy if their components are copy, which is cool. Okay, so I think this just solves it. I have not written very many tests in the middle here, but feels relatively straightforward. Cargo test problem 4. Okay. Unable to open file. Yes, it would help if I downloaded the file that has the problem in it, the input in it. That would help. Put 04 and paste. And I guess we can look at the first 10 or something. So it doesn't fully contain, does fully contain. So it's 1, Nope. Yes, that's 2, 3, 4, 5, 6. So 6 in the first 10. 6 in the first 10. So, okay, so I think we're expecting 2 of these to pass. Yep, and we get all the way to the end of the file, meaning that indeed 542, whoops, 542. Oh, also, did I think I didn't actually put in the answer here for 3. Cargo test problem 3. What's problem 3? 2508. Okay. Just so that we get to see the test go green, always nice. Okay, problem 4. We get 542. Let's see if that was the right answer. 542, 542. Bingo. Okay. That one was easier than 3, I felt. Part 2. It still seems like there's quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs, blah, blah, blah. Okay, overlap at all. Okay, so this is just going to be one more function. Lost my repo. Here we go. This is just going to be one more function. So let's go ahead and copy. Go ahead and copy this down. And we'll assert problem 4b. And in their example, it is 4. Okay. So, overlapping at all. So I guess I should rename this function, yeah? This should be has completely, or let's say completely overlapping, has completely overlapping, versus overlaps. This takes a pair, returns a bool. And what to say here? What to say here? So there are 3 cases, well, 4 cases. But maybe what we do is just say not our sequential pair, and we'll say our sequential. I'm being verbose here, but I think it is nice to be verbose and leads to fewer errors. And so here we'll say our sequential in order or our sequential in inverse order. And then our sequential in order will be let's see here. Let left, right be pair. Left dot 0 is less than right dot 0, and left dot. Is it just left dot 1 is to the left? I think it's just left dot 1, right? Left dot 1 is less than right dot 0. That works, and then our sequential in inverse order. And in this case, it's going to be, can we just flip them? Does this work? Maybe this doesn't quite work, because what if left is to the right of right? Then well, then left dot 1 is certainly not to the right. Okay. I think this works. So our sequential in inverse order, we should just be able to say pair 1, pair 0. Just trying to picture this. Make sure there's not some weird case. So like, so like 3, 6, 2, 8 should be false. Left dot 1 is not to the left of right dot 1. And in order to make it, I would have to make this a 7, in which case it would become true, so that seems fine. And if they were in another order, we could have something like 7, 8, and 2, 3, in which case left dot 1 is way bigger. Okay, I think that works. So that's to be pair. Okay. Cool. And so then this should literally just be the same thing, except this is overlapping. Overlaps. All right. And what do we get? Where is our puzzle out? Where's our test output? Ooh, we got a Stack Overflow. Nice. Okay, what did I accidentally do? Ah. That would do it. Our sequential in order. Okay, and we need to, so this passed, and we need to look at our shortened input, which is the first 10 of these. So, yes, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Okay, and 8 is what we got. Alright. And 900 is the answer. Alright, let's try 900 as the answer. Boom. Boom. Alright, less than an hour. I wonder if we can even get through all of problem 5. Let's find out. Now that I've said that, we'll probably get stuck on the beginning of problem 5, but that's okay. We'll work through it. Cool. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure that none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. Okay? The elves don't want to interrupt the crane operator during this Talia procedure, but they forgot to ask her which crate will end up where. And they want to be ready to unload them as soon as possible so that they can embark. They do, however, have a drawing of the starting stacks of crates and a rearrangement procedure. Your puzzle input. Oh man, the parsing in this is going to be annoying. In this example, there are 3 stacks of crates. The rearrangement procedure is given. Okay. It's going to be all parsing. Okay, the elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, Z in stack 3, so you should combine these answers and give the elves the message CMZ. After the rearrangement procedure completes, what crate ends up on top of each stack? Okay. Yeah, this is going to be all parsing. Sort of. It's kind of interesting from a data modeling perspective. Let's get to it. So first we get our puzzle input. Which I failed to copy. And okay, we're gonna need some special parsing here, I think. So let's just start with a function that's actually, let's start with some data modeling. So let's make some observations. What's the process going to be here? What's our code meant to do? Well, first we're going to need to parse all this stuff, and we want to parse it into some structure that's useful to us. So I think that's probably going to be roughly 2 things. So one is going to be some data structure that says, here's what each of the stacks have in them, and I know how to move things around within that data structure. And the other is going to be something that encodes each of these moves into an instruction that we can then pass into the data structure, update, and spit out the answer. So we kind of want to first parse into some sort of input, load them into the data structures, and then just run it. So let's do the data structures first. Let's treat this as being object oriented. And let's say let's write some tests. So test stacks can move boxes. Okay, and we'll say let stack be box or stack stacks. Let stacks be stacks new, and maybe we go ahead and use the example. So the example was, we'll do a vector, and we'll do 3 vectors. Zn MCD and P. And then we'll say, and that's got to be mute. And then new, what's this yelling about? Stacks new. Oh, I just haven't updated it. Okay. And then we'll say stacks dot move. We can't use move. Move box from move box 1. Actually, let's just say move box. Let's say let instructions be instruction new 1 to 1. I'm just taking these from the example. Instruction new 3 1 3. Instruction new 2 2 1. And instruction new 1 1 2. And stacks.move all, or move boxes, we'll say, instructions. Assert equal stacks.top get top boxes will be C M P. Okay. And so this is like fairly typical of how I think about more like object-oriented problems. Is let's write a test. Let's start from the top and like drill down. So here's a test that pretty much does the whole thing, the whole problem, but in terms of the data structures that we expect to implement. And then let's do one more test that's just stacks can move box, and we'll just do one movement there. Stacks stacks.move box, and we'll say instruction new. Let's move box 2. Oh, are these indexed in an annoying way? These are indexed in an annoying way. Okay, so I'm actually going to decrement all of these by 1. I want these to be 0 indexed. 2, 1, 0, 2, 0, 2, 1, 1, 0, 0, 0, 1. Not quite. These don't need to be decremented. These are the amounts. Okay. Okay. So this is move 3 from 0 indexed 1 to 0 indexed 0. Okay. So let's move box 1 from stack 2 to stack 1. Then we expect stacks.get stack 1 to be MCDP, and we expect assert stacks get stack 0 to have no elements, and we expect stacks get n boxes to still be 6. Okay. Seems good. Couple other things. Let's test that the instruction parses from string. So we would want assert equals instruction from string something like this, and we would expect that to be an instruction of from 3, 0, 2, because we wanted 0 index things. Yeah, I can't really imagine. Oh, and I guess we'll make this an okay. All right. Cool. XL Mila says Vim plus mouse. Yeah. I'm still learning Vim. So I sometimes jump to the mouse. It happens. Okay. And last but not least, I guess I want to make sure that we can parse the stacks from a string, which is probably going to be the most tedious part of this. So stacks parses from string. And what to say here? I guess we will have an input that looks like suppose. Can I do this? I should be able to. T-string. And we will want, I guess let's just, let's do, let stack be, stacks, plural, stacks, from string s, just unwrap this for the sake of the test. And then we want stacks dot get n boxes to be 6. Stacks dot get stack 0 should be this guy, NZ, and so on and so forth. MCD, and I don't feel the need to do the other one. Okay. Oops. All right, so these tests ought to more or less do it. And so now maybe we just need one function that knows how to parse the whole problem. So parse inputs. Input can be a vector of strings. And what do we want out of this? We want stacks and a vector of instructions. And so here we'll say stack string and instructions are if we have to find maybe the easier way to do it actually is to just take the whole thing as a, whoops, let's just get one big string, and then we'll say let stacks string instructions string is input.split. What does split add do? I have to give an index, that's the one I want. Split on 2 new lines. I guess we'll actually say, I don't know, chunks seems fine. Let's collect these as a vector. We'll check that indeed there are only 2 chunks. And then we'll say stacks string instructions. String is chunks 0, 1. And then for stack string, we want to get rid of the bottom because that's the thing that just has the indexes in it. So we can say stack string is stack string dot instructions. Collect this as a vector. And then I guess we'll do it this way. Stack string is stacks string 0 through stack string length -1. There might be a nicer way to do that, but I guess we can .take maybe. Let's do that. Into iter.take stack string length -1 dot collect. Meanwhile, oh, and then we have to join these back together as one long string. Do I join on strings or do I join on, I don't remember. I think I do it this way. Join stack string. Is it on a character? Oops. Getting my Python confused. Let's look. Rust join. Equivalent of join. Do. Stringless.join. Does it. So I shouldn't need this. And I can just join this way. Okay. And I guess I have to define what this is. Great, so that gets us the stack string, which means we should now be able to get the stacks. Enable to parse stacks. And then our instructions should be pretty easy. Instructions is instruction string dot split on new line, and then we map that into instruction from S unwrap. Oh, we need to expect unable to parse instruction, and I need to format this. Input. Cool. And I realized this needed to be expect. Okay. And then we return. Stacks instructions. All right. So that should let us parse. And now let's just implement the two types, and we should be good to go. Struct instruction is the easy one. Let's say number to move is a usize. Let's say from stack and to stack. And then I think the only thing we need here is new and from string. And for this, we expect to get, what do we expect to get? We expect move something from something to something, right? So, I guess I kind of just want to get characters and pop stuff off of it, because the instructions could be different numbers, could be different sized things. How big is our problem input? Okay, so yeah, so there are tens in here. So we have to handle multiple digits. I would kind of want to handle multiple digits anyway. So let's see here. Chars equal s.chars. Oh, but I saw already that actually. Can I even do this? This might be one of those cases where, oh, it can split up by word though. That's going to be the way to do it. Let words be s dot split on, we can just say split white space. Collect. And then assert word one is move let number two move be words one dot parse into a usize dot expect couldn't unwrap parse number to move. We'll assert that words two is what? Is from. And then let from stack be words three. Parse that into a usize. We will expect, we will say couldn't parse from. And then we will subtract one. Next word should be two. And then finally, to stack should be words 5.parse usize expect couldn't parse 2. That's 1. And then we return, I guess rather than panicking on these, we should just kick an error out. So I guess I can say map error on each of these. And then say, no matter what, kick this out. Does that work? Parse. And then I have to map this to n-1. And then I can use the question mark syntax. Yes, that works. So this can be map error again. String. Map. Okay. And then if we get this far, we return number to move from stack to stack. We wrap that in an OK. Okay. So hopefully that's that. And then we need the other one, which is stacks. And there's going to be a vector of vectors, basically. Of characters. And so we have a few things here. We have get stack, which should return a vector of characters and amounts to saying, I guess it can just return a reference to a vector of characters. And we can say self.stacks n. It seems important that we actually provide that self in here. We also had get n boxes, which is just self.stacks.iter. dot count, c dot length, dot sum. And what else did we do? Get stack. Move box, of course, and from string. Okay. Oh, we don't need that. Okay, so put function from string. Result of self for string can be what? So this is going to be let row strings be s dot split void space collected into a vec of string. And then we say let stacks, let mute stacks be an empty vector for row string in row strings. Say for I row string in row strings dot iter dot enumerate stacks. That's a vector of strings. It's row string, that's a string. So if we go through each row, it's sort of annoying that this counts from the top down. Eek. Okay, let's do better than this. So let's say stacks is so let's say row boxes, and we'll say dot map row string self parse row string. And then we'll write that function in a moment, and we will take, and then we can go through these, and we'll say for I box in row boxes, let's see here, each one of those is going to be a row, so now it's going to be a vector of option of care. It's going to be a vector of boxes for care, so I in row boxes, and I also kind of want to reverse this as well. going from the bottom up. Dot iter dot enumerate for j entry in row stacks j dot push entry return stacks return self new of stacks. I think that should be about right. It doesn't like the types, but that's fine. And so now this will be parse row. And here it's going to have those annoying brackets. So we'll probably just go through the characters one by one. Let me to return be an empty vector for C and S dot chars and what to do. So we're expecting isn't quite what we want. Let's say because I want to be able to pop multiple columns off of multiple strings off of this. So ideally I'd do this a little bit more like a tokenizer. Chars equal s dot chars dot collect as a vec, and then while chars dot length is greater than 0. We can pop characters off of the front, so let maybe left bracket be chars dot pop left or pop front. Why do I kind of think there is no such pop front? Something has a pop front though, no? I feel like I remember doing this. Cross the back pop front. I do not want to drain. Oh, a vec DQ has pop front. Um, it's probably fine. So, match, maybe left bracket. If it is a left bracket, then I guess we're always popping though. So let's let maybe care. B cares pop front. And maybe right bracket. B cares pop front. And I just want to see in the input, is there a space? Yes, there's also a space. So I'm going to just strip the white space out first if I want. How do I do that? Strip white space is a thing, I believe. No. I could strip white space. Well, I can just say let maybe space. Okay, so then match maybe left bracket. If it's a none, then to return push none. And if it is a left bracket, then to return push. By the way, this should return a vec of an option of a care. Then we will push OK. Maybe care. Dot map. Or I mean, string ended prematurely. String and so that's map. Something like that. That's not quite right though. Not quite right. I'm just gonna panic here because we know. Am I gonna panic here? Prematurely. But really, this should be a result. Yeah, we'll have to see what to do about that. This isn't quite right. Think about that a little bit. Okay, and then if anything else, we return error. Oh, there should be a sum. We return error of it's if this is a space. Got an unexpected character. This. The character we can give a name to. And we return an error. This needs to be a toString. Oh, this needs to be formatted. Okay. So that will grab the character. Or return nothing, and then at the end we want to return. Should be okay to return. Okay, and this should be okay this. Not okay, some. All right. And last but not least, this probably needs to be a debug string. Okay, and so then the only question in here is what to do. How do we most conveniently kick an error out of this one? It's probably just to open up a pair of brackets here and say what let's see equal, or just maybe match, no, let's see equal match maybe care, none, we return error, string ended prematurely, and if it's some, then we can kick that back. And then we don't have to deal with this. We can just say some C. Okay. Okay. So now, so we split on white space, but we're getting back a bunch of results. So this needs to be a vector of, can be a vector of whatever I want it to be. Row string. And okay, now we get a vector of results back. But I don't quite want that. If I just put a question mark here, does this work? No, it doesn't. Would be cool if it did. Oh. Wait, parse row returns a result. This function returns a result. But the closure doesn't return a result. Okay. Well, we can just do it here. Match row. Or let's just say, let's call this row result. And let's say let row equal row result. Kick that out. This can go into iter, that's fine. Okay. Same here, right? This can be into iter. Okay. And then this ends up being okay, new stacks. And this, I'm surprised this can't figure out what it needs to be. Okay, this needs to be match entry. Sum, then we do this. If not, then we do nothing. Sum entry. Maybe entry. None, we do nothing. And then I paste the row like that. Interesting. Did not know that. Okay, and then stacks needs to be known. Interesting. So this is a vex of chars. And this is just entry. Making progress. Good, because I gotta wrap up in the next 12 minutes. Okay. So let's say from string here. Let's say the collect here. Let's say string here. Stack string dot length borrows it. Oh, it tries to borrow it. Okay, so I should be able to just say let L be this, and now it's fine because it knows that it was borrowed and it's returned. And then we need move boxes, and we need get top boxes. End boxes, let's get top boxes. And this will be a vec of care. And this will just be self.stacks.iter.map stack stack.last collect. I guess we can return a reference, and I guess this needs to be a reference, and oops. Stacks iter stack.last. Ooh, that's fair. What happens if a stack is empty? I assume that can't happen. But just in case it can, let's map is there no or else? No. And then I just want to map it if it's none. Or else. Okay, or. Oh, that's cool, but that's not what I want. Map doesn't do what I want. Or doesn't do what I want. Wait, does or do what I want? Here we go. Unwrap or. That's what I want. And then I guess this needs to be a reference. And then I guess this whole thing needs to be can't return a reference to a temporary value. Okay. And the only problem here is that it's a reference to a temporary value. Oh, I see. Okay. So basically I'm going to end up having to clone this anyway, so I should just return a vector. Okay, so that should get the top boxes, and then the last one is move boxes. Or move box and move boxes. Self instruction. Needs to be mute. And so let's number to move from stack to stack, the instruction dot unpack. Move boxes. Move box. Let's actually call this handle instruction. And then we'll say 0 number to move. Go from 0 to number to move. And we'll say self dot move box from stack to stack. And then this will be move box stack usize to stack usize, and we will say what? We will say let box be from stack dot pop I'm running out of time, so I'm just gonna unwrap this. Expect tried to move a box from stack with no boxes, and then to stack dot push B. Sorry, from stack should be self dot stacks from stack, and this should be self dot stacks to stack. Okay, and then last but not least, we can say handle instructions. And this is just instructions into iter for each self.handle instruction I. Okay. And we just need to be able to unpack an instruction. Okay. So move boxes we will rename to handle instructions. Get top boxes. These need to be and instruction from string binary operation can't be applied to type. Sure, let's derive all of the usual stuff. And we can do debug. Probably it for that one. Okay. I gotta go. For test problem 5. Okay. Basically everything failed. One of them passed. Which one passed? Okay, that one passed. This one fails. Why does it fail? Index out of bounds. From string. Let's just write a test for parsing the row quickly. Let's let row let s equal this. Then we want to ensure that instruction, no, stacks, parse row s should be z m p. Oh, these can be options, right? So sum z, sum m, sum p. Does equal that. And if I take this one, what's the nicest way to do this? Something like this. Let s be this. expect N, C, and none. Which is what we got. Okay. But then this is failing. Alright, well, I need to run, so this is where I will start next time. Just wrapping this one up and hopefully getting 5B out of the way soon. But hope this has been interesting. And please follow and subscribe if you haven't already. It helps me out. And I will catch you all soon, either tomorrow or Thursday, for the next set of these. Hope everybody has a good one.